Hi girls, we're going to continue our chat today about adaptations to exercise, specifically looking at oxygen uptake. So oxygen uptake is the body's ability to absorb oxygen through the lungs and into the blood for use throughout the body. Okay, oxygen uptake increases in response to training. We're talking chronically over a long period of time, lots of training, not just one bout of training, and allows for faster and more efficient delivery of oxygen to the muscles. Now that's important for a number of reasons, including the fact that the quicker the muscles get the oxygen, obviously the more we can remain in the aerobic system, which is beneficial because it doesn't have any limiting byproducts and it has a big payoff in terms of ATP. It's also beneficial because it means that our muscles are getting nutrients that they need quicker. Now, one reason for increased oxygen uptake in response to chronic training, long-term training, is that you can get an increase in hemoglobin and myoglobin levels. So if we talk about hemoglobin as reason one, hemoglobin takes oxygen around the body. That's the transporter, okay? The more hemoglobin that you have within your blood, the more oxygen per milliliter of blood can be transported. Reason two, as I mentioned before, is the myoglobin, increase in myoglobin, which takes the oxygen out of the blood and transports it into the muscle cell for ATP production. So obviously the more of each of those that we have, the more efficient our aerobic system will be, and the less that we rely on anaerobic systems, which have those limiting byproducts. Now, if our hemoglobin increases, it's really beneficial. Because obviously it increases the body's ability to utilize the aerobic energy system, as I've mentioned, which delays the need to rely on those fatiguing factors. If we can't utilize oxygen enough, we go straight into the anaerobic system, in particular, usually the glycolytic system, meaning that we're producing pyruvate, and if we can't recycle that quick enough, we're fermenting it into lactic acid. And as you know, the pH of the blood becomes acidic, which is a limiting factor to performance. So with more hemoglobin, as I've said, if we make this more eloquent, therefore it results an increased hemoglobin level increases the workload at which an athlete reaches their anaerobic threshold. So the anaerobic threshold is an exercise intensity at which you start really producing lactic acid at a rate of knots, okay? So this allows the athlete to maintain higher intensities for longer periods of time because they remain within the aerobic training zones, okay, in the absence of those limiting factors. So the more hemoglobin you have, the more intense you can train and still remain within the aerobic zone, okay? Make sure that you've taken notes today. Go in search of more information on the net, and we'll chat more in class.